Hi friends, I wanted to explain the focus and directrix of a parabola using my friend here, Melvin the spider. One of the interesting things about Melvin is that he has his 8 legs, and each of his legs have the same length from his head to his knee and from his knee to the ground. So each of these parts of his leg are the same length. And the fun thing about this is that if we were to connect the dots, so say that we put a dot at each of Melvin's legs, at each of his knees here, and we were to connect those dots, we would get a parabola. And the interesting thing about Melvin is that his face here, that is the focus of my parabola. And all parabolas have a focus. And the ground here is the directrix of my parabola. And all parabolas have a directrix. Now, it comes back to the definition of Melvin's legs having the same length from his head to his knee as from the knee to the ground. So remember we said that this distance and this distance are the same length, and this distance and this distance are the same length, as are these distances here. Likewise, on a parabola, the distance from the focus to the parabola is always the same as the distance from that same point to the directrix, some vertical or horizontal line on the opposite side of the parabola from the focus. One of the other key pieces of information is that we have our vertex on the parabola right here in the middle. And similarly, the length on the parabola between the focus and the vertex and the directrix is the same length. And we can call that length the focal length. So these are just some new key features of a parabola that we didn't talk about in our quadratics unit in the fall, but that we do want to understand when it comes to conics and that you will be using going forward in mathematics, especially in pre-calculus next year. So just to recap, we have the focus. It's a point on the inside of the parabola. We have the directrix. It's a line outside of the parabola. The distance between any point on the parabola and the focus is equivalent to the distance between that same point and the directrix. And that same thing goes for our vertex. The distance between the vertex and the focus is the same as the distance between the vertex and the directrix. And that distance between the focus and directrix is called a focal length. And because that is the same as the focal length here, we can also call this a focal length, and we abbreviate that using the variable c for focal length.